Hello everyone, in this video we're going to look at homework 2.6 which is due today. And first question, y equals 2x squared, the graph. If you graph this function, it's a even function. Even function is f negative x equals fx. Well, it's very obvious. The first one is a linear equation. Second one is a cubic. The third one is square. The fourth one is absolute value of x. So the answer is C. Very obvious. Pretty simple. The domain, there is no denominator and no square root. Okay, this is most often conditions which we have to pay attention. So there's no restriction for this equation, for this quadratic equation, okay, quadratic function. And then the domain of the function is negative infinity to positive infinity. Okay. Next one. Which graph discontinuous at many points? Here is the range. Which of following graph is discontinuous at many points? So B is continuous everywhere. It's okay. C is continuous from 0 to infinity. Okay. And D is continuous from 0 to infinity. But A is discontinuous at many points. You see, it's at many points. Okay. So A is going to be the right answer. And choose the correct range below. So the range only have, you see the range is -5, -4, all the y values. Range is all y values. Y values is, the y values for this graph, we can see the y values only have 0, 1, 2, 3, 5, 4, 5, like step function. Okay, so the range is just all the integers. The function is continuous from, okay, this one, the function is continuous. If you look at the picture, it's from 3 to infinity. So this one is going to be, okay, so I just write down here. So the function is continuous on 3 to positive infinity because the domain is from 3 and 3 is contained because this is a dot not open circle. Okay, so it's 3 to infinity. This is the answer for this one. Alright, this one is pretty simple. F -4, -4 is less than -2. So we plug this one equals 3 times is first function. 3 times -4 is -12. Okay. Okay, next one, F -2. -2 is still plugged into the first equation because -2 is on the top one. 3 times -2, which is -6. Okay, let's continue. F0 is 0 is bigger than -2, so we have to plug into the second function, 0 minus 4, which is -4. Okay, so F2 is bigger than -2, so the 2 plugged into the second function is -2. F5 is bigger than -2, so plug into x minus 4, so it's 5 minus 4, which is 1. Okay, this is going to be the same function, piecewise function. So -2 is less than equal to 1. -2 is less than equal to 1, so plug into the first equation. So f -2 equals 4 minus 2 times -2, which is 8. Okay, so when you do this kind of function, you just say the domain -2 is at which one? Is less than -1, so it's going to be plugging to the first equation. Okay, so it's 8. Second one, -1 is still plugging in the first one. Let's continue. It's just a pretty simple one. Just plug in. Okay, look at the function. Is a constant function. It's a piecewise function. Less than equal to 1 is -3. And bigger than 1 is -2. So 1, 2, 3, and then after that, so it's D. Okay, so number 7, graph the function. X less than -4 is y equals 2 plus 2x, which is a linear function. Go -4, so -4 is right here. -4 is -6, so it's here. Like this, okay? And -2x. When x is -2x from here, -2 plug in. When x is -4, then is -2x. So -2x you graph from -4 to +5. Okay, -2x for this one. -2x, -2 times -4 is +8. -2 times 5 is -10. So go to -10. Okay, because it's equal on both each sides. Now we don't have to graph more because it's very obvious it's going to be here. Okay, number this one, x cube function, x plus 4, and this is another square function. So first, x cube plus 4, we can tell this is going to be a function. First is like this, and then you shift it in the top by 4 points, like that. Okay, so if it's -3 to 0, so you have half of that, just like here. Okay, and is 4. Okay, and then x plus 4 from 0 to 1. So 0 is 4, and 1 is like this. You have to do a linear equation. 1 plus 4, so it's 1 plus 4 is 5, so it's come to here. Has increased a little bit, okay? And then the other one is 5 plus x minus x squared. And we can plug it in. For x equals 1, it's 5 plus 1 minus 1, so it's still 4. X equals 2, 5 plus 2 minus 2, which is 7 minus 4, minus 4 is 3, so it's going down actually. So now we can tell it's going to be C. Okay, number 9. What is true? Give a piecewise function, give it a domain. So the first one you find in the function is y equals x. So fx equals x. You can see that it's just x is passed through. It goes through -3, -3, and -4, -4. So you can tell the function. The first piecewise function is just equals x. The second function less than equal to -3. Second one is just a constant function, 2, positive 2. And you also have x is bigger than -3. It's -3. Okay. The domain is -infinity to +infinity. Domain is -infinity to +infinity. There's no points which is undefined. So you have -3 is defined here. It's undefined here. It's okay. So the whole domain is still defined. Next one. First class postage with a private post service cost 0.34 for all weights through 1 ounce plus 0.28 for each ounce or fraction of an ounce thereafter. Each letter is required to carry 1.34 as many 0.28 stamps as necessary. Graph the function that models the number of stamps y on a letter weighting x cover over the interval 0 to 5. So first, everything has to give you 0.34. Now 3 through 1 ounce is 0.34, and always through 1 ounce plus 0.28 for each ounce, so it's 0.28. Okay, even 0, I think it's that. And then after you got 1, I don't know why it's 1 here. It should be 0.348. Let me see. Right, because for all weights to 1 as plus point for each ounce fraction, then after each carry 1 as many as them 5, the function that models the number. Oh, the number of stamps. The number of stamps is if first one is at least 1. Then after 1 ounce you put 2, and then you go through. I think it's going to be this one. Okay, so because the 0 you don't have anything, 0 ounce you don't have to. I think you don't have to put anything for 0, and then after 1 ounce you have to put, I believe is you have to put about two stamps if it's 2 ounce through 1 ounce. I think you still can put a 1 ounce for 2, for 1 ounce for 2, and then after that you have to put more. Okay. So lumber that use the frame wall house is furnished solely in multiple 2 feet if the length of the board is not exact a multiple of 2 feet. There is often no charge for the additional length. For example, if a board measures at least 8 feet but less than 10, the consumer is charged only 8 feet. Okay, so it's kind of like step function. X divided is x over 2, and the less than, if choose the small is the biggest, or sorry, less than the value. If it's less than 10, you choose 8. Okay, so but it's past 8, 10, you choose 10. Suppose the cost of it is 0.8 every 2 feet. Find the formula for the function of x every 2 feet. Okay, so you have divided by 2. And compute the cost x feet along a cost for a length of 8.6 feet, so you just have 8. So it's 8.6 divided by 2, which is 4.3. Okay, by the integer it's going to choose 4 times 0.8, so which is 3.2. Okay, you finish the other one. It's 15.2, and you continue with the same method. Okay, so we set button to use the radical select to compare the graphs of square root of 2, square root of x, square root of 4, square root of x, 6 square root of x. What types of symmetry do this radical function exhibit? So you look at the function here, you only have the function is like this. You don't have anything here, don't have anything here. Because it can't be negative, you don't have this. So you have to be positive, so it's neither. Alright, so the range is, second range is 0 to infinity, but it contains 0. The graph of the function you can tell is 0 to infinity. 0. Where is the comma? Zero to infinity. Back. Okay. So next, look at the next one. 14. Checked box zoom set is the true or false that x equals c, or for square root of x. Okay, for square root of x, you draw the picture is square root of x. And then, if it's true or false that if x equals c, and c is less than 1, bigger than 0, then fc is less than c. Well, you check that FC is less than, say FC is like this. So you can find that function FC is like this. This is 1 and this is 0. So FC is y equals x. This is y equals square root of x. Okay, which we got that this is, if any point have a c here from 0 to 1, so c is less than square root of c from 0 to 1, and which is false. Okay, and what interval the function increasing? A function increasing at what interval? So click reset button in upper right corner, check the show plot box on what interval is the function increasing. I cannot see the function, but I will see if I can. Let me check in my other. Homework about this function. Well, if you cannot see it, well, just click anything and it will pop up with the same question. Because I really don't like this kind of questions, but next time we probably will get rid of all of this. So just say try again, if you really cannot open it. So it's -3 to 0, right? Alright, so now what do you need to do? Try again. You just put -3 to 0 here. It should be right. Most likely for this question you have 1. Okay, so you made it right. Right, so now we're done with this section. This is 2.6. I think let's continue with 2.7. Graphing techniques. Right, so match the equation column 1 with the correct description column 2. So x minus 4 is a transition unit 4 to the right. Because if x minus 4, you can set up x minus 4 equals 0, so x equals positive 4. Okay, first one, let's just say it. Y equals x minus 4 squared. What do you need to do? X minus 4 equals 0, x equals 4. This means 4 units to the right. It's positive 4, right? Positive 4 is on the right hand side. So units to the 4 to the right, so it's B. Next one, y equals x squared minus 4. This minus 4 is not working on the x value. It's actually working on the y values. Okay, compare this one, the -4 is with the x together, so it's x direction. This -4 is not with the x, so it's y direction. So shift it down because you subtract 4, so it's decreasing. So shift down 4 units. So it's A. Oh, for the mix A. 4x squared is multiplied. Okay, so multiplied by 4, so it's stretched by a factor of 4, so it's E. X plus 4 squared, y equals x plus 4 squared. Okay, the 4 is with the x together, so x plus 4 equals 0, x equals -4. Okay, you can see -4 is to the left side of 0 point. So shift to the left. Okay, last one, you up. So you choose it up. Okay, next one. Graph the function below. So just click the graph function and you choose that. Oh, it actually give you this vertical like this. And 3/4 rise over 1, so 3, 4, and I have to go to 3, 4, choose 3, 4, 1, 2, 3, 4. It goes to here actually. Yeah. So x equals 3, rise over 1. So 1, my bad, rise over 3 is rise 3/4. My bad. I have to clear this. So rise 1, 2, 3, run 4. Okay, rise 1, 2, 3, run 4. Rise will run. And then we got it. Negative 7x. Okay, so I just graph it right here. It's rise over run, negative 7 like this. Okay, y equals negative 7x. So rise, well, you don't rise 7, but you run down 7 and run over 1. Okay. 6.611 is on the graph y equals x. Find a point on the graph function y equals, if y equals f, x plus 5. So previously have f6 equals 11. Now whenever x plus 5, you can look at the function is going to be on the graph of f x plus 5. So x equals 1, then the whole thing equals 6, right? So you got x equals 1, the value is 11. So the point it should be 1, 11. Okay. Okay, so next one, x plus 5. We got 6, 11. f6 equals 11. Now you get a plus 5, so you have f6 plus 5, which is 11 plus 5, which is 16. You add 5 on the y values, basically. So you get the point is going to be 6. This is fx is 6. Add 5 on the y values is 6, 16. The second one is 6, 16. 6, 16. Oh, just that one again. I want to use this one to do that thing. It's just so hard to type in. 16. Great. Next question. The graph of y equals x minus 1 is symmetric with respect to a vertical line. What is the value of that line? So x minus 1, y equals x minus 1 is symmetric with x equals 1. Because previously the function is like this. The function is like this, symmetric with y equals y-axis, right? Now it's x minus 1. X minus 1 means you shift the whole graph. You shift the whole graph to 1 to the right-hand side point. Okay, because x minus 1, x equals 1, so shift to right. Then you shift to right-hand side by 1 unit. So this is y equals x minus 1. Now the symmetric is x equals 1. Okay. Without graphing, determine whether the following is has a graph that's symmetric with respect to x-axis, y-axis, or none of this. So what you need to do, you check f negative x, see if it's equal fx or negative fx. Okay, now let's check it. F negative x equals negative x squared minus negative x plus 10. So this equals x squared plus x plus 10. Compare this one or with fx equals x squared minus x plus 10. Well, this is the same, this is the same, this is the same, but these are different. You have either all the same or all negative. Either all of them is exactly the same, or all of them are opposite. But now, half are positive, half are the same, half is opposite, so it's neither. Graph the function fx x squared equals a, this is pretty, I'll just graph one of this. X squared, so just do negative 8, it's right here. Oh, just click it. I think it goes up to, okay. Vertical stretch, nothing. Horizontal stretch, nothing. Vertical shift, yes. We do have a vertical shift. Vertical shift is negative 8 because you shift it down. Okay, just check it. And then we're done with it. There's no vertical stretch, no horizontal stretch. Vertical shift is negative 8. Horizontal no shift, so that's it. Okay, so I'll skip this one. I think it's okay. Okay, so just shift down. Graph the following. So x, y equals square root of x plus 3. The square root of function is like this. And x plus 3, you got x plus 3 equals 0, x equals negative 3. Negative 3 means shift to left by 3 units. So it goes to here. So y equals x plus 3. You shift the whole graph by 3 units to the left, which is D. Okay, x plus 7 square. Oh, sorry, x plus 7 cube. Okay, I'll just do this one. You have to choose this. Okay, choose this and click it here. And you don't have the vertical shift, vertical stretch, no. Horizontal stretch, no. Vertical shift, no. Horizontal shift, yes. What is the horizontal shift? Because you plug at, just to set up x plus 7 equals 0, then x equals negative 7. You shift to the x by 7 units to the, wait. Okay, shift to the 7 units to the left. Okay, it's pretty simple too. Let me see what's that. The horizontal translation apply the graph. What do you know about applying from a given graph? This is okay. So this function, you can see previous the function is like this. This is the y equals square root of x. Now where does it go? It goes to here, to the point shift to negative 1. Okay, 1, 2, 3, 4. So to 4 points to the left. You can tell that it's 4 points to the left. Okay. Well, we continue. Translate what? Up. 1, 2. So it's 2 points up. Okay. And then what is horizontal stretch? Check the picture. Does it have multiply anything? Plug something. So you look at that. Is y equals square root of negative x. Okay. Plus you shift to the left, so it's x plus 1, 2, 3, 4 plus 4. Okay. Now you plug that in. So you just check that previously you have 1, 1. Now you're negative 4 plug into here, and a negative 4 plus shift to 2, right? Now let's check it. What about if x equals 0? Well, x equals 0, y is what? X equals negative 4, y equals 2. X equals 0, y equals 0 is 4. But x equals 0 now, x equals 0, y equals 0. So, let me see. Shift the translate 4 to the left, x plus 4 units. Yeah, goes to here. Then up, and I still have to do that negative. Okay, so x equals negative 4, y is 2. X equals 2, x equals 0, y equals 0. So there's no stretch. Okay. And the shift, but it reflects with the x-axis. Okay. Give the equation of the graph. This is the equation of the graph. Okay. Assume that f3 equals 2. Assume that y equals fx symmetric with respect to y-axis. Find another value of the function. So if it's symmetric with the y-axis, you get 3, 2 here. Then you have another point at negative 3, 2. Okay, so you got f negative 3. Negative 3. 2. Next one. You have that function coming again. So from this one, I just can tell this is a fourth even function. I just from a small picture, it's going to be like this. So it's even function is even power, so it's going to be C. No, it's not. It means that's not the right one. Okay. Oh, it asks you which of the following is not even function. The cube is not even function because cube power can't be even. You don't have to even use the picture. Okay. So this one, select even box, and that's the even function. Move the x, compare the coordinate of display for any even function. The point is on the graph of f. What must coordinate another point? Okay, the point, the other one should be, if it's even, the other one should be -2, and also -15. It was -15, right? Okay, so +2, -15, +2, -15, and the next point is going to be -2, -15. Now next, this one, we set button square root of x, and use the C slide to change the values when C is positive. What is the true of the transformation of x plus c? So fx plus c, which is equal square root of x plus c. This means shift the function to the c point to the left. Okay, c to the left, just the c units. Okay, we just got it. And number 16. And x squared, this is fx equals x squared. Now fx squared plus d, which is x squared plus d. You add d. If d is positive, let me see. Well, d is negative now. So d is negative is x squared minus some point, for example 3. So if it's d is negative, you shift it down the units. Okay, so we're done with that. It's a pretty simple section as well. So now let's stop here.